Welcome to day 5 of our 12 days of Ec 10. Today's topic and tomorrow's topic are both welfare, and today we're going to focus on specifically consumer and producer surplus, government revenue, externality costs and benefits, so that we can look at how individual groups are affected. How are consumers happier or less happy about a policy? Are producers going to favor opening up to trade or getting a subsidy? Questions like that. For those types of questions, we need to focus on the individual components, so we'll need to use the techniques discussed in this video. So there are 4 components for social surplus. Hopefully you remember them all. There's each one represents what a different group in society cares about. So there are consumers, and they get consumer surplus. They're the buyers in transactions. Producers get producer surplus. They're the sellers in transactions. Usually that's all we hope to be involved in a transaction. The buyer and seller, who else would care? If you sell me an ice cream cone, I can get some surplus, you can make some profit, we're all happy. But sometimes the government gets involved, it puts a tax, or it subsidizes that ice cream sale, and then they care about how many ice cream cones are being sold, because that's going to affect their tax revenue. And then on rare occasions, or maybe they're really common, I think for our purposes, though they're rare, they're a separate set, is when there's externality costs or benefits. So for instance, if someone else really dislikes the smell of ice cream for some reason, and you sell that cone to me, it might really bother them, and they'll get really upset and cry, or maybe they're allergic to the smell of ice cream somehow, and they'll get sick because of you selling me that cone. So we'll have to worry about the cost to them, or conversely, if their health was improved by the cone, perhaps it could be a benefit to them. Consumer surplus is defined based on willingness to pay or marginal private benefit. They're the same thing. So marginal private benefit, willingness to pay. And basically the idea is a consumer's demand curve, right, this guy, which is also tells us what he's willing to pay, or in other words, his private benefit, like how much he benefits in dollars from buying some stuff. So suppose this was the demand curve, then suppose he bought the stuff for a price of, $4. And then this curve here, the demand curve, tells us what he was willing to pay. So clearly he was willing to pay more than $4 for all these cones. That's why he bought them. And let's say he bought 5 cones. And then let's label them out. First cone, second cone, third cone, fourth cone. Well, when he bought that first cone, so right here in this space, he was willing to pay this much. And you might say, well, which much? I pointed out like a lot of different heights. Well, they're all approximately the same, right? This line is locally about, let's say, has a height of 8. So he was approximately willing to pay $8 for that first cone. So he's going to get surplus because he paid $4. He was willing to pay 8. So all of these $4 are like are like net benefit to him. So he gets $8 of surplus. Then we can repeat the exercise for the second cone. There's going to be, he paid $4, but he was willing to pay something a little bit less than 8, maybe like 7 or 6. We also get some surplus on the third cone, and the fourth and fifth. So we're basically filling in this whole area, except for a few like missing little tidbits right here. Like this is white space, so what does that represent? Well, the great economist Archimedes, before the birth of Christ, figured out that in the limiting case, when we think of this as being like many, many cones, so not just 5 cones, but like thousands and thousands, maybe 5 billion cones, all of these little spaces go to 0. They're basically negligible, so we just ignore them and pretend like the consumer surplus is this entire space, so that you can calculate the area easily. It's now just a triangle. But remember to focus on the intuition. You're getting surplus because you are willing to pay, say, $8 or $6 or something above 4, but you only had to pay 4. If we gave you a table and said you were willing to pay $10 and you bought for 5, it should be intuitively very clear that the surplus to you was $5, and that's all this graph is really showing. Producer surplus, very similar. So they have this concept of willingness to sell. It's sort of the flip side of willingness to buy, and they get a marginal private cost because they have to pay like a cost to produce things. It can't be done for free. If nothing else, they have to take the opportunity cost to provide the service, which will take, they'll have to give up something like time. So their willingness to sell curve is, as you'd expect, the supply curve tells you what they're willing to sell for, and it also tells you their marginal private costs. And now they're going to get paid presumably something above their private cost. If they were paid something less than their private cost, it's not clear why they'd want to sell. Why would you sell for $2 if it cost you $5? That's not going to get you surplus. That's going to like hurt you and give you a deficit. So let's suppose they were being paid $5, and then for the first unit, number one right here, let's say that they sold 4 units. For the first unit here, let's say they were willing to sell for $1. Because their marginal private cost was $1. It cost them $1 to produce this unit of, let's say, ice cream, 1 scoop of ice cream. Well, then as before, their benefit, they're getting paid $5, and they were willing to sell for $1. So all this space in between, this $4, is net benefit to them. So we can shade that in as a type of, as producer surplus. And then we can repeat the exercise for the second, third, well, this is really not to scale, and fourth unit. So all of this would be producer surplus 2, because they're getting surplus on each of these units. And then once again, we have this like sort of empty white space, but Archimedes assures us, the great economist Archimedes assures us that that white space kind of goes to 0 if we think of this as a large market. You probably studied this in your math class, and it's referred to as the second fundamental theorem of calculus. So now we come up to the tricky part, the part that bugs everybody, externalities. So externalities are anything that affects someone who is not the buyer, the seller, or the government. And really, technically, the government is a special type of externality called a fiscal externality. So if you take higher level classes, it'll just be producers, consumers, and externalities in general. Government falls as a special subset. So I'm going to refer to everything as an externality benefit. So EB equals, and then you might say, well, what if the externality is negative? Then what? Then we should call it a cost. That's true, but you can just represent that as externality benefit being negative. So that represents an externality cost. These ones are the easiest to calculate. You don't really need the graph to calculate them, because usually there's some externality benefit or cost of, say, E dollars. So it's usually a constant of E dollars per unit. So we have E dollars per unit, and then we have, say, Q units. And it should be very intuitive to you that the same way if you bought 5 apples for $2 each, the total cost is the product, 5 times 2 is 10. If you're paying a cost or getting a benefit of E dollars per unit, and you buy Q units, it should be the product E times Q gives you the total externality cost or benefit. So EB is E times Q. It'll be negative if it's a cost, because then you should be looking at this as like a negative E per unit. It'll be positive if it's a benefit. And then how can you visualize this on the graph? Everyone screwed this up on the second midterm, so let's do an example here. Suppose we have MPB here and MSB here. So what type of externality is this, real quick? Positive consumption, right? Because the benefits are up here above the private benefits. So this distance between the two represents some kind of benefit. The marginal externality benefits, like benefit to some third party. Okay. And then suppose that, let's say 3 units were sold. Well, then we know that if there's, and then let's say this externality benefit is $4. So this is 8 up here. This is 4 down here, so the gap is 4. And we said it's constant, so it would be 4 here and 4 here. So we know that there's going to be some area of 4, that's the externality benefit, times 3, the Q, so $12, somewhere on this graph. Where is it? Well, there's 3 units, so this is going to be sort of the width of it. And then the height is given by this guy here, right? The gap between MPB and MSB. So if we just shade in all of that gap between MSB and MPB, between 0 and 3, this parallelogram, we get the externality benefit. And a parallelogram, this parallelogram is just like a rectangle that's been pulled to be sort of tilted, right? If we pushed up on the right here and pulled down over here, we'd get the rectangle that we expect to see with width of 3 and height of 4, so it's $12 like we expect. Accounting for externality is not meant to be difficult. It always shows up as a parallelogram, as pretty much, as long as it's a constant cost per unit or benefit per unit. And you don't usually need to use the parallelogram to calculate the cost and benefits. The easiest way is to just use EQ. Just use common sense. Government revenue is a lot like externality benefits. It's really straightforward. Again, you don't really need to use the diagram to calculate it because you know that if there's a tax of $T per unit and you bought 10 units, you would pay $T for each of those 10 units or 10T. So if you bought Q units, it would be T times Q. This is basic common sense. All of you have known how to calculate the tax on things you buy since you were, probably 6 or 7 years old, maybe 8. I guess 8. Most people learn to multiply when they're 8. So you would have been able to calculate the tax you owe on a hamburger. If it's 6 cents per hamburger and you bought 3 hamburgers, you could have told me when you were 8 or 9 years old that you owed 18 cents. It shouldn't be any more difficult now that you're doing it in college and you're much, much older. That said, if we need to visualize it on a graph, our tax will be the gap between PB and PC. So we'll be told that it's like 5 up here, 3 down here. That means the gap between the two, our tax is $2. Then we have some number of units, let's say 5. So we're going to have some rectangle, just like the externality benefit, right? We had E times Q, so we got this blue rectangle, although it's kind of pulled on its side, so it's a parallelogram. Here we actually don't have to hold it on its side. It's just going to be height, width. So here's our tax on the diagram. So now that we've calculated for each of our components of social surplus, our components of welfare, we just figure them out each individually, right? We can do CS, PS, externality benefits or costs. They'll show up as negative if it's a cost, and government revenue. Government revenue. So let's do an example exercise. Suppose we're asked to calculate the social surplus or each of these individual components on this diagram. A welfare table is the right way to go because you're asked for the individual components, right? So you want to list out CS, PS, EB, GR, and just do it slowly and methodically. Don't, spend a lot of time like trying to overthink it. Just count up for each of these individually. Don't shade. Usually you wouldn't be asked to shade because areas will overlap and it'll look like shit. So just take it one by one and make a table. So here our consumer surplus is going to be the price consumers pay. So that's PC, right? Not PP. This is how much they paid. This must be the, this is poorly labeled, but let's suppose this is marginal private benefit. This is marginal social benefit. And then this is marginal private cost. So I should have added that in at the start. You shouldn't assume that. Okay, so this tells us what consumers are willing to pay. This is their private benefit. This is the price they're paying. So all of this area is surplus to them. So consumer surplus would be A plus E plus F. And now producers are receiving what price? PC or PP? Hopefully it's pretty obvious it's PP. So this is what they're getting paid. And this is how many units they're selling Q star. And then they were willing to sell for this much. So all of this space represents surplus on the first unit, the second unit, and so on. So their surplus is going to be G plus E plus C. Now we have to worry about externalities. Q star units are produced, right? So we're going to have this as the width, and then the space between MSB and MPB, or if there was a production externality, which there isn't, it could be between MPC and MSC. But there's only one externality here. It has this height, right? So between here and, we could extend the line out if we needed to, if we wanted to, just to visualize it. For this many units, so it's going to be this parallelogram, BCD. And then finally, we have to worry about government revenue. Is government revenue positive or negative here? Producers are receiving more than consumers are paying. So I'm going into the store, I'm paying $1, and somehow you're ending up with $2. So is that a tax? No, couldn't be, right? If it was a tax, I would pay $10 and you'd only keep 9 or something like that. This is a subsidy, so we're going to have some negative government revenue. Specifically, it's this big of a subsidy between PC and PP on this many units Q star. So all of this ECDF is government revenue, but it's negative. So it's minus E minus C minus D minus F. So now I calculate each of the components, so we can answer any question they're interested in, like, suppose we changed Q. What would be the new CSPSEB government revenue? What would be the change in social surplus? What's the social surplus here? Just add them up, and so on. This took a long time, took like 5 minutes, but remember on a problem like this, you would have probably 20 or 30 minutes to do the blue book. So go slowly and do it. It's easy. If you get this wrong, there's really no sympathy for why you got a C in the class. Finally, we're asked about deadweight loss sometimes. What is deadweight loss? Well, there's a much better answer that we can give you, and we will give you that in the next video, but it relies on thinking about the big picture for society. If you're using tables, usually deadweight loss just means change in social surplus. So you calculate once, you calculate again, and then you compare the social surplus in the two cases. So now I want you to pause the video and work through this problem on your own. Calculate each of the components on this trade diagram. So there's QD labeled and QS labeled. So this is the amount supplied, this is the amount consumed. And calculate externality benefits, externality costs, externality benefits / costs, government revenue, producer surplus, consumer surplus, and then tell me the total social surplus with trade. Don't shade anything in, just don't even recopy the diagram, just work through the problem and calculate those 4 things. Oh, I should have mentioned that this is an export quota, so QS is less than what you'd expect. You'd think it'd be here where supply intersects world price, but it's actually here because there's restrictions on exports. So this would be the price in the market. Okay, so hopefully you got these answers. Consumer and producer surplus are quite straightforward. Consumers were getting some surplus because they were buying from domestic producers, and they were, getting a little bit lower price than they would if there was just free trade. So they got not just A and B, but also C and D. Producers were getting a lower price because of the export quota. They couldn't sell at that high world price because they weren't allowed to ship that many units overseas. Oh, I left out a little area. I forget what that area is labeled, but plus some other, I forgot. On the ones they actually do get to export, they get paid a little bit extra, and I left out that part. Forgot the label. The only trick here was, first of all, what is government revenue? Is a quota. So there's no tax, there's no subsidy, so government revenue is 0. And then the externality benefit was just B, D, and F. The reason is that this is a consumption externality. So you only get this externality when things are consumed. And the amount consumed was QD. That was the amount people actually purchased and then used. QS tells you how much people sold, so it's relevant for production but not for consumption. So we wouldn't get any externality costs or benefits on the goods that were exported, basically. All right, so in summary, social surplus has 4 components: consumer surplus, producer surplus, externality benefits or costs, and government revenue. Tables are really easy, but they're very difficult to do all at once. You don't have enough working memory to work out all the parts of all the table at once, so you're going to have to do it piece by piece. When you do it piece by piece, you can't really get it wrong because it's so easy, but if you do it all at once, you're almost assured to get it wrong because you don't have that much working memory. Don't overcomplicate things when you work with tables. Don't try to intuit the answer of there's going to be a lot of deadweight loss, or there's very low social surplus, very high social surplus. Just make the table, look at the answers you got for social surplus. If there's 2 scenarios that you have to compare the 2 amounts of social surplus and get the deadweight loss, and then try to make sense of what is going on. If you try to guess the answer ahead of time, that's great, but you're probably going to get it wrong. Whereas if you just do the work slowly and carefully, the answer will be obvious at the end. Thanks for watching our 5th day of Act 10, 12 days of Act 10. Hopefully your studying's going well. Email if you have any questions.